Hello all, I'm Namrita and today I'm going to explain about data structures in Python. In simple terms, if I have to define what is a data structure, so I will say a data structure is a particular way of organizing data in a computer so that it can be used effectively. A data structure is nothing but a collection of data values. There are four types of data structures in Python. First is lists, then tuples, dictionaries, and sets. Today we are going to talk about list in details along with some real-time examples and other data structures we will discuss in the upcoming sessions. So let's get started. Let me first tell you about some properties of list. Lists are an ordered sequence of mixed data types. Lists are written as comma-separated elements within square brackets. Lists are mutable data types. When I say mutable, it means you can change the elements present inside a list. There are various operations being performed using lists in real-time use cases. First is indexing, slicing, membership in list, concatenation of list, replacing values, difference between extend and append, deleting or dropping elements of a list, sorting a list. Each of these operations we will understand with examples in Python console and Jupyter Notebook. So let me move to Python environment now. So this is a nested list. Why I'm saying it's a nested list, because if you recall the properties of list, we mentioned that a list is a comma separated elements within square brackets. So these are square brackets, and inside the external square brackets we can see there is an internal square bracket also, and you can see the mixed data types also. One is string, one are numbers. Now let's move to the first operation, that is indexing. I'll explain you like how indexing works. So if you see there is a list with some elements presented in Python. Uh, so Python gives internal index to the elements of the list starting from 0 to so on till the last element of the list from left to right, and it also gives the negative indexing starting from -1 and so on to pull the elements in reverse order from the last. So what I mean in a layman terms, that it gives us the internal indexes, that is starting from 0 from left onwards, 0, 1, 2, 3, 4, 5, and in the reverse order it also gives internally the indexes from -1, -2, and so on. So now if we have to fetch the first element of a list, we have to basically write a square brackets of 0 because it's starting from the 0th index. So if we print this statement, we'll get the first element. Now if you want to fetch the last element of the list, we will write as list, the variable in which the list is stored, a of square brackets -1. It will give us the last element. Now if I want to fetch the second last element, that means this element I want to fetch it, so I'll simply say a -2 in the reverse order. So it will give me this entire uh, thing which is present in this position. But now if you see in the output, we are getting two items in the list, 1995 and 1996, but I only want to see 1995. So what I will do, a square brackets -2 because it's in position -2, but in -2 it's a position of 0, so I'll write another square brackets and make it as 0. So it will give us 1995. Now let's move to the second property, that is slicing. So when we have to slice, it means that I want a range of elements from a list. So in this, I have mentioned I want a range of elements starting from 0 to 2. But how slicing works, if we mention 2, it always takes as n minus 1. So if I mention 2, it will only go to 0, 1. It will not go to 2. It will stop here. So if you see the output, you have got the output Namrata and 8080. Let's see another example of indexing and slicing. So here is a list. It's also an index list. Like it is also a nested list. Now if I want to fetch the first element, that is chemistry, I have written the code as L of 0. Now I have to slice and pick the first three elements. It is first three elements, that is 0, 1, 2. So I've got the output here because it goes from n minus 1. Now let's move to the third property, that is membership in list. So if you see, it's a list, and now I want to check whether some particular item is present in that list or not. So let's suppose I want to check whether 2 is present in this list or not. So I'll simply write print of statement 2 in L1, that is in this variable. Now I have to check whether 10 is present in this list or not. So I'll write 10 in N1. Now the output of these two corresponding print statements, first one is definitely true because yes, definitely true, 2 is present in this list. That's why it has returned as 2. Remember one thing, membership thing that is in clause will always return, give us the output in either Boolean statements, that is true or false. And the second print statement 10 in L1, that is definitely false because we cannot see 10. Now let's see how we concatenate the list. We had original list, that is L, this one, and now I want to append another elements in this list. So I'll simply say, I'll basically give a new variable and I'll say L plus these elements needs to be appended at the last. So now if you check, 5 and 8 has been got concatenated in the old list, that is L. Replacing values, replace biology with maths. So biology is of 0 and at present at the first index of a list. So I'll simply write new L of 1 and then replace it with the value which I want, that is maths. So now if you see the output, it is chemistry, maths instead of biology, and everything remains the same. Difference between extend and append. I'll show what extend does and what append does. So it's a list and I want to basically add these two elements at the end of the list. So I'll simply write L dot extend and square brackets passing these two elements. Now just observe the output. It is the same list till 8 and it has appended two new elements, that is 202 and 55. Now if we check append, I will simply take a new list and I'll append these two elements. But now in this case, you will observe in the output, it simply appends these two elements with a square bracket. It's not taking individual elements like the extend take it. So what essentially I'm trying to say, the difference between extend and append is, extend takes individual elements inside a list and then append those lists at the end of the original list. But append does it like it simply considers it that one object. It does not consider that these are separate elements and simply go and append these at the last of the list as one object. So it's inside a list again. Now deleting or dropping elements of a list. So this is the command to drop any individual elements of a list. So let's suppose I have to drop 40. from my original list. So I'll simply write del L1 of 0, and now just let's see the output whether this element has been removed from the list or not. So if I'll see yes, it has been removed. Now the new list is starting from 1 and so on. How to sort a list? Sorting a list is very important in real time use cases. Eventually been asked like let's sort the data frame in ascending order of date and so on. So if it's a list, you'll see it is a list, and now we have to sort this list. Now is right now it's in unsorted manner. So it's very simple. We just have to take this list and we have to do dot sort, and when we see the output, it's in a sorted list. So that's an end of the session. And if you please subscribe our channel if you found the information useful, so that you stay tuned and do not miss any of the upcoming lectures.